We are still working in section 2.2, trying to understand limits. And right now we have a theorem that we need to make sure we can apply. So please make sure you understand this theorem 1 limit laws here. Simply this says that if I'm taking the limit of a function as x approaches some number c and it becomes L, and the limit of another function as x approaches c is m, then I can look at what happens if I add those two functions and I want to take the limit, or I subtract those two functions and I want to take the limit, or I multiply one of the functions by a constant. Okay, so all of these rules you need to look at and understand. This is real simple. It's kind of like you just say I can distribute the limit through here. So the limit of f of x as x approaches c is L. The limit of g of x as x approaches c is m, so I just add those. If I have a constant inside, the constant can be pulled out in front of the limit. That's the best way to look at this. So when I pull the constant out in front of the limit, then I have the constant times this limit, which is L. If I multiply the two functions, then I can take the limit of one and multiply it times the limit of the other. That's why I get L times M. If I divide the two functions, I can take the limit of the numerator, divide it by the limit of the denominator, then it's L divided by M, as long as M is not 0. If M is 0, then this is undefined. If I take the nth power of a function, then what I can do is I can imagine moving that limit inside this power. So then it just becomes the limit of f of x as x approaches c, which is L raised to the nth power. So same way if I have an nth root, which is a power 1 over n. It works the same way. Okay. Now if n is even, we have to, of course, if we're taking a square root, then I can't have L be negative because you can't take the square root of a negative number. So understanding all of those rules, if you come down, I gave you an example here on page 18, example 11, where let's suppose that it doesn't matter what these functions are at this point. Suppose that the limit as x approaches 0 of f of x is 1, and the limit as x approaches 0 of g of x is minus 5. So whatever we've done to get those limits evaluated, we have them. So let's evaluate this kind of more complicated limit. The limit as x approaches 0 of 2 times f of x minus g of x divided by quantity f of x plus 7 raised to the 2/3 power. Okay? All right, so basically the way to look at this is the overall thing I got going on is a division here. So I take the limit of the numerator divided by the limit of the denominator. Then I can break up the numerator into its two pieces, 2f of x and g of x, take the limit of each, subtract them. And I can move, in the denominator, I can move the limit inside the power. So the limit of quantity f of x plus 7, all raised to the 2/3 power. Then again, I keep working my rules. In this one, I'm going to bring the 2 out front. I'm going to bring the 2 out front of this limit. And down below, I'm going to break this up into 2, limit of f of x plus a limit of 7. And then I just plug in all these numbers. The limit of f of x is 1, so it's 2 times 1. The limit of g of x is minus 5, so it's minus a minus 5. Again, limit of f of x is 1, so there's my 1. The limit of any constant is just that constant. Okay, it doesn't matter where x is going, that constant will always stay the same. So 1 plus 7, all raised to the 2/3 power. Do some simple algebra. 2 plus 5 is 7. 8 to the 2/3 power is the same as 2 squared, which is 4. So your answer is 7/4.